Hello and welcome to another video on my channel. In this video I'm going to talk about a very interesting topic when we're using Java, which is called operator overloading. So if we have different objects, mathematical objects, we can overload the default math operators in Java, which is plus minus, to get some functionality or implement some functionality between objects of the same type. So a little bit of background. Math operators in Java are plus, minus, times, division, modulus, and equality, which is the assignment operator, right? These are the basic or typical math operators that we use. Now these operators are basically defined for the compiler to be used only for primitive types, okay? So int, long, float, double, these are the typical that we normally use. Int and double are the most typical types of primitives that we use when we're dealing with math, right? Or computation in general. Now Java has built-in wrapper classes. This is very interesting. So wrapper classes, we talked about this before. They basically are objects. So wrapper classes are objects that encapsulate or enclose a primitive type. So integer object or integer class, long, float, double. So I'm going to highlight both the integer and double because these are the most useful wrappers for us, okay? Now by definition, Java allows auto boxing. What is auto boxing? So auto boxing means if I go to my IDE and write double, which is an object, remember x, so x is an object, equals 2.3, which is a primitive. So I'm saying that this object is equal to this primitive, right? I mean, by the definition of the way the Java works with assignments, this is not allowed, right? Because you cannot assign a primitive to an object. However, the way that compiler handles this is basically this expression is equivalent to double x equals new double 2.3, okay? This is the way that you use this wrapper class double. Or double x equals double, you call a method called, it's a static method called value of. And this takes a primitive double and returns an object of type double, a wrapper. And this is called a simple factory. If you are familiar with this kind of definitions of factory methods, these are basically a static method, and the value of is basically the most simplest factory that we can use, okay? Now when you write double x equals 2.3, after the compile of your Java code is finished, or during the compilation, the compiler actually replaced the right hand side 2.3 with this method double dot value of 2.3, okay? So when we write in Java double x equals 2.3, it's just a convenient way for the programmer to write things, and this has been defined for the compiler to, whenever it sees this expression, it replaces 2.3 at the compile time with double dot value of 2.3. So if you actually go and look at the bytecode that is loaded in the JVM, you see that the bytecode is actually for this method. So it refers to some kind of method like this, okay? So Java, this is called auto boxing. You take a primitive type and the compiler automatically injects this code at the compile time. Similarly, Java compiler supports auto unboxing. Unboxing means let's say you create an object of type double equals 2.3, and we know how compiler handles this, and then you say, okay, a primitive type double y, it's a primitive type double, equals x. Remember, x is an object, so x by definition refers to object reference, but then on the left hand side this is a primitive type, so it has to have the value. So how does This is generally not allowed, right? But the compiler knows how to handle this. So it takes x, the object x, and replace this at the compile time, replace x with x dot double value. So this is another method, and it's an instance method. It's not a static method. So compiler replace this x, this double object, with the x dot double value method. Okay, and this is some sort of code replacement or code injection that the compiler automatically does for us. So when we write double y equals some double object, it's just a convenient way for us, and the compiler knows how to handle the actual logic of programming in Java behind the scenes. Okay, now compiler replaces this x with x dot double value, and it creates the bytecode for this expression, double y equals x dot double value x, and then this expression is being loaded into JVM. Okay, now there are also other examples. For example, object double x equals 2.3, which is a primitive, double y equals 1.2. So x and y are object references, not primitives. But then you can say, okay, the primitive double z equals x plus y. Okay, and the way compilers handles this is first now this is where there is an operator plus between two objects or object references. Okay, x and y, remember here in this example, x and y are not primitives, x and y are objects or object references. So the compiler first does as soon as it encounters this plus between two x and y, it realizes that okay, x and y are double objects, and it knows how to handle this through the auto unboxing. So compiler first replaces x and y with this x dot double value method and y dot double value method. So it first does auto unboxing, and then uses the plus sign to operate on the unboxed values of these two double objects. Okay, now one step further, even if you say double z, so now z is a object or object reference, not a primitive, equals object x, which is double plus object y. Now this takes two steps for a compiler. It has to first because compiler only knows how to calculate the result of a summation plus between two primitives, right? Two double, for example, two double primitives. So compiler first does the auto unboxing on the x and y, which are double objects. So it replaces this x plus y with x dot double value plus y dot double value. And now it has two primitives, and the plus sign is defined, and it then calculates the result of the operation of the summation, okay, after the auto unboxing. But then it realizes that there is a primitive on the right assigned to an object, and this is not allowed, but the compiler knows through auto boxing that now it should replace that expression with the value of method, so double dot value of. So behind the scenes, this double z equals object x plus object y, and x and y are doubles. This becomes double z equals double dot value of x dot double value plus y dot double value. Okay, that's how the bytecode is being generated, and then that bytecode is loaded into the JVM. Okay. Now other variations also work. For example, x is a double object, 1.2 is a primitive, and we are adding an object x to a primitive. So by definition this is not allowed, but compiler knows it has to first does the auto unboxing on x and then add it to another double primitive and calculate the result, and then do auto boxing. Okay. Now this auto unboxing obviously, as you can probably tell, it's inefficient when you compare it to just calculating, doing the computation using the primitives. So one of the effective Java items is that whenever you can do your computation using the primitives, just use primitives, because auto boxing and auto unboxing are not efficient when you compare it to the operation between primitives. Okay, so using wrappers to do the operation is not as efficient as using primitives, but it's an option and the compiler knows how to handle that. Okay, and this expression, for example, double z equals x plus y. So x, y, z are objects of the same type, and this plus sign is acting on two objects and returning an object. We can define it as some sort of operator overloading that is pre-built or predefined for the Java compiler. And the definition is that this plus sign, which is basically defined for primitives, now is acting between two objects and returns another object. In this case, the defined behavior is auto unboxing and then auto boxing, as we discussed. Now, what's the problem here? The problem is that Java compiler only allows operator overloading for built-in wrapper classes. For built-in wrapper classes, these are the only cases where the auto boxing, auto unboxing are defined for Java compiler. Okay, and the built-in classes are built-in wrappers are integer, double, float, and this kind. Okay, byte, short, these wrapper classes. So for this, compiler has no problem. It does auto unboxing and auto boxing automatically, and that helps us write the cleaner code when we're dealing with these objects. Okay, now unfortunately Java compiler doesn't allow general case of operator overloading for any object. So it doesn't allow. Operator overloading is not allowed in Java by definition. But why? Now, typically the reason that is given is type safety. Java is an extremely strict type safe. So basically type safety in Java is very important. Okay, and arbitrary operator overloading may lead to runtime exceptions, not the compile time. The compilation may be fine, but then the problem is that when you add two objects, the two objects might not end up being of the same type, and then there has to be some sort of typecasting on the result, and that may not be possible, and that's only an exception during the runtime. Okay, so type safety might be violated, or it might have severe type safety issues, especially at the runtime. And the other thing is that basically Java is using object-oriented programming, and OOP is typically used to model real-world scenarios or real-world objects. For example, when you have an object of type student, or I don't know, user, operator, this kind of stuff, you cannot add two students together, say student 1 plus student 2. It doesn't make any sense, right? So in most cases, objects are not some sort of entity that you can add them together or subtract them. Even most of the math objects are not, doesn't make any sense to have these kind of math operations between them. But in some cases in math, we actually want to have this capability. For example, so when we're dealing with math, in most cases, operator overloading makes sense, at least to have it as a capability. And Python, the good thing about Python is that it actually supports, it has a built-in support for operator overloading. You can overload anything in Python. But again, Java, because of its type safety philosophy, it doesn't allow it for any arbitrary object. So for example, if you have two vectors, vector x and vector y, so x and y are objects of type vector, it's really nice to be able to write vector z equals x plus y. So summing or adding two vectors makes perfect sense. So if we could overload this plus sign for two vector objects, which just arbitrary objects that the programmer defines, then this is very nice. And vector is a math entity, is a math object, and plus makes sense. On the other hand, dividing two vectors, x divided by y, doesn't make any sense, right? That's why I made it red. So even for math objects, some of the math operations make sense and some don't make any sense, right? That's another reason that Java decided not to allow arbitrary operator overloading. But for example, very useful math objects are functions. So if I have two objects of type function x plus y, I can have all sorts of math operations between them. Multiply object x by y, and it should return a function. The result should be a function. Add a primitive 2.3 to a function object, and it has to return another function. Even with matrices, right? In linear algebra, if I have two matrices x and y, it's very nice to be able to write x plus y. So have two matrix objects and have the plus operator operate on the two of them and returns another matrix z, which is the result of adding two matrices. Multiplication also makes sense between two matrices. Division in general doesn't make any sense, having one matrix divided by another. Okay, so division of two matrices doesn't make that much sense. But plus and times, or maybe just having a matrix A and matrix Y, and Y is basically X, let's say 2 times X. Having a number multiplying having a matrix multiplied by a number also makes perfect sense, right? So in some cases, it's very nice to be able to have the operator overloading capability. Now Java doesn't allow it, so what do? That's the $1 million question. So there's a work around it, and that's basically having an extension to the compiler, or basically exactly the way that the compiler handles this operations for this built-in wrapper classes. We give the compiler a capability or an extension so that it can be able to overload these operators for any type of object based on the behavior that the user defines. Remember, this is the key, based on the behavior that the user defines for the objects and the operators to act on two objects of the same time. Okay? So how to add operator overloading capability to Java? This is IDE dependent. So first of all, go and read this paper. This is a very interesting paper, and that's what I'm going to use. It's called Java Modular Extension for Operator Overloading. And the concept here is basically using generics in Java. Using generics in Java. If you're not familiar with the generics in Java, you can just Google it. But that's basically the idea behind adding this extension or this capability for operator overloading to Java compiler. And you can read this PDF file, and it goes into the details. Now, if you want to set it up in Eclipse, step 1 is to install Scala IDE for Eclipse. So there's this plugin, Scala IDE for Eclipse. You can just search it on Eclipse Marketplace, or you can Google it, or you use this update site for Scala IDE. After you install it and you restart Eclipse, step 2 is install the compiler extension library. Install operator overloading support, and that's an extension as a plugin for Eclipse, and it's on GitHub. github.com AMELENTEV/Java-operator overloading 00. And if you go to this address or Google operator overloading in Java plus GitHub, you can easily find this website. Okay, so this website, and in this website there is this address, update site for Eclipse. So you add this to Eclipse, and I'll show you how to do it, and then you restart Eclipse. So let's head to Eclipse and see how to do this. All right. So first of all, if I go to About Eclipse, I have this Scala IDE plugin already installed. Okay. And then if you go to Help, Install New Software, and I already have added the operator overloading update site. Okay, and I have already installed this. So when you install it, you are able to use operator overloading, and the Eclipse behind the scenes does the code replacement for you. Okay, so that's kind of like compiler doesn't do it. Compiler only do it because it knows how to do it for the built-in wrapper classes. But when you install these plugins for Eclipse behind the scene, when it generates the bytecode, it does add those code injections and replacements. Okay, so the whole idea of operator overloading is that it makes life much easier for you as a programmer to be able to write cleaner codes when you're dealing with objects. Okay, all right. We installed the Scala IDE plugin for Eclipse. We installed the operator overloading support for Eclipse from the previous slide. And now, if you want to add the operator overloading capability to a custom defined object, you can implement any of these 6 basic methods. Okay, one is a simple factory. So if you know that if you want your object to support assignment to a primitive, let's say your object, let's call it A, equals some number 5. If you want your object to support this assignment to a primitive, you have to implement a static method that is called value of, exactly just like the wrapper classes that we discussed. And they also had this simple factory value of. Okay? And you replace this object with your class name. Okay, replace object in this code, in this slide, with the name of your class. For example, if it's called vector, instead of having object, write vector, static vector, value of. Okay, and so if you want your object to support assignment to some non-object type or objects of different types, you can do this. And you can define how this assignment behaves. For example, if I say my object A equals some integer value, and I want the compiler to understand that, so I have to have this static object value of, and the parameter argument should be an int value. If I want my assignment to be understood for a double value, I have to have a value of factory, a static method. Remember, the factory methods are static method. Factory methods are static methods. This value of method just takes care of the assignment. Okay, let's say I want to have an object equal to another object. This is more like copying. So if it's just typically 2 objects, it copies the reference of that object, but you can overload it with this value of method and then implement a deep copy. Or maybe it's just you want this assignment to be basically you want this object, let's say another object, object 2. Let's say I have another object V, object 2V. I want to have my vector. When I say vector A equals object 2 something, some object of another type, I can even overload that. And that's a very powerful thing, right? So the assignment of different objects now makes sense and can be overloaded. Okay, now if I want my object to support overloading for addition, let's say I have object A, object B, and I want object A plus B. Again, replace the object in this code with the name of your class, for example, vector. If I have, for example, a vector plus a vector, I have to have this method, vector add. The name should be strictly this, add. And if I want to have be able to add 2 vectors, this parameter should be vector V. And then I write the body for this method. What happens? It has to return a new vector. Now I might want to have a vector and add a constant number, an int number to a vector. So I can implement add with the argument in. Now addition is a symmetric operation, so I can say A plus B or B plus A. Okay, So a plus b, let's call it add. B plus a is reverse add. So add REV, reverse add. That's why we have this add REV, add reverse, okay? So for each of these math operations, we have a operation and we have a reverse of the operation. Addition, addition, reverse, okay? Subtraction, subtract REV, subtract, reverse. Multiply, multiply, REV, reverse, okay? So again, a minus b is subtraction, b minus a is subtract, reverse, REV, okay? The multiplication, a times b, reverse, multiply, reverse, is basically b times a, okay? So in order for compiler, because which object goes first in a binary operation, b times a or a times b, in general matters, especially for division or subtraction. For summation or addition, multiplication, it doesn't matter, but for division and subtraction matters. So divide, a divided by b, and division or divide, reverse, is basically b divided by a, okay? Now when I, for example, say when I call this method object divide object v, the divide means the direct calculation, the direct definition, which is this divided by whatever object is inside the parameters or argument. And when we say reverse, it basically tells the compiler, okay, take the argument as the first operand and then divide it by this object. So these are equivalent, okay? And finally, we should be able to have some negation, because negation is equivalent to 0 minus a, but negation is a unary operation. So 0 minus a, the compiler knows how to do it because it's a binary operation. But if you don't define, if you don't explicitly define negation, compiler doesn't know how to handle this basically unary operation. So we also have a negate method, okay, and returns my object type, for example, vector. So if I have a vector, I write minus vector or minus a, then it has to return another vector whose components are all have a negative sign, okay? Now you can go back and look at this PDF file. There are more stuff. For example, you can even implement logics, or XOR, this kind of logics for your object, okay? But for our purpose, for the math purpose, these 5 methods, value of, add, subtract, multiply, division, negation, negate, and the reverse of the operation, add reverse, subtract reverse, multiply reverse, and divide reverse. These are the most important ones that we typically use for our, or we want to have for our math objects, okay? Now the way that I use it, the way I typically use this is through an interface. So and I normally use generic. So look at this code, public interface operator overloading with a generic type T, okay? So this operator overloading interface is parameterized with type T, okay? So I'm using the generics capability of Java. And then I don't add the value of methods in the interface because those are static methods and they have to be a static method. If you define the value of factory as a non-static method, it doesn't work. You have to define it as static. But you cannot define a static method in an interface without implementing the body, okay? All the non-static methods are abstract. So you don't write the body, they're just templates or placeholders. Whatever class that implements this interface has to explicitly implement these definitions. So in this operator overloading, which is parameterized with type T, I always add the addition, add reverse, And here I just implement those for the type T, object T. What happens if I add two objects, or adding the double number to objects? So I'm ignoring the float and int, and you don't need to actually do that because compiler automatically does typecasting. Okay, so you add int, it automatically converts them to double, and float also double, so there is no loss in converting from int to double. So you're safe. Addition, subtraction, multiplication, division, and negate. Okay, and these are all parameterized with type T. As I mentioned, because factory methods are static, the simple factory method was the value of the factory methods, which was value of method. Okay, static, implement them in the class itself, not in this operator overloading interface. Okay, now here's an example. We talked about a vector class. Let's call it's a 2D vector. So a vector v can have two components, let's say x and y. Okay, an x component and y component, and we want to define this vector 2D class and then implement the overloading for addition, subtraction, multiplying by a real number, a double number. Multiplying two vectors don't make any sense. It doesn't make any sense. So we want to have the addition, subtraction, multiplication by a double number, or division by a double number. And the reverse division doesn't make sense. So basically what I'm saying is that if you have a vector d divided by 2.1, it makes sense. Okay, but if you, so this is okay. But if you have a vector v and 2.1 divided by v, this doesn't make any sense, right? And again, the good thing about this way of dealing with operator overloading is that you don't have to implement all of these methods. You just implement the ones that make sense for your object. Okay, all right, let's head to Eclipse and see. I already created a demo OPOV, operator overloading Java project, and I have already written this operator overloading interface, which is parameterized with type T, and I have adding to a double value, adding to a reverse double value. So I'm going to write this one more time. This is basically my object O plus V. This is reverse adding V plus O. Let's write it capital O, object, and this is object O plus or maybe instead of O I should say this. Whatever class implements, add means this plus V. So this object comes first plus V. Add reverse means the object V plus this. So the parameter or argument comes first and then plus. Again, similarly, add is this plus object V, and reverse add is V plus this. For the addition, this doesn't make any difference, but for subtraction, subtract is this minus V, subtract reverse is V minus this, and it makes a difference. There is a difference in the results. Okay, and if I want to implement vector, as I mentioned, the multiplication by another vector doesn't make any sense. So I'm going to comment it out. Division and then reverse division doesn't make any sense. Division by a vector doesn't make any sense. So these are the methods, overloading methods that for a vector make perfect sense. So let's create our class. Let's call it vector 2D. And let's implements operator overloading. Okay, and for type we type it vector 2D. Now let's see what happens. Eclipse automatically generates the right code with this parameterized type, which is the type of my class. Okay, that's the power of generics. It automatically replaces that placeholder type T with the actual parameter or the class type that I define here. Okay, now my vector 2D has a double x and y it has coordinates, and then you can have public vector 2D double x double y, a constructor to initialize that this equal this y equals y. Okay, so I create my vector. Now, does the assignment make sense? So if I have a vector x, or let's say z, if I say this is equal to an array of a and b, does it make sense? Yeah, it could make sense, but let's not just implement it. Let's just implement the addition. Let's just force the user to use a constructor to create this object. Okay. Now, what happens when I add this object to a double value? Obviously, I'm going to assume this double value adds only to the you can define it in various ways. I'm going to assume that this double adds to both the x coordinate and y coordinate. So what I have to return as a result is a new object vector 2D and x plus v, y plus v. Okay. Reverse addition, what I'm going to return is a new vector 2D object and v plus x, v plus y. Okay. Adding to another object, so what I'm going to return is when you add a vector to another vector, the x components add separately and the y components add separately too. So I return a new vector 2D, this dot x plus v dot x, this dot y plus v dot y. Okay. Now note that even if we define this, right now x and y have a default access modifier. So these are these triangles, which means these have package level access. Even if these are defined as private, I still can write this v dot x because I'm inside this vector class. This is something that usually people don't understand it very well. Okay, even if this is private, I am still within these two curly brackets. As long as I'm within these two curly brackets, physically I'm here. I can call a vector object, vector 2D object, and call it x coordinate without any problem. Okay, even if that's private. Okay, when I'm reverse adding a vector to my vector 2D, new vector 2D v dot x plus this dot x, v dot y plus this dot y. Okay. Subtract. Now addition, reverse or direct doesn't make any difference, but for subtract it makes a difference. So new vector 2D. So in subtraction, this comes first. This dot x minus v, this dot y minus v. I'm assuming that a double number just subtracts from both coordinates. Subtract revision, new vector 2D v minus this dot x, v minus this dot y. Okay, a new vector. Subtract from a vector 2D. In the subtract, this object comes first. So new vector 2D, this dot x minus v dot x, this dot y minus v dot y. And again, even if these x and y are private, I can access the x and y, the private fields of this v argument or parameter without any problem, because I am inside this object right now, physically here. Subtract revision, subtract reverse is a new vector 2D v dot x minus this dot x, v dot y minus this dot y. Okay. And multiply by a number is basically, we already know that it just multiplies to both components. So new vector 2D, v times x, v times y. Multiply reverse, doesn't matter, new vector 2D, x times v, y times v, and divide by a number new vector 2D, x divided by v, y divided by v, and when I negate a vector, the x and y coordinates are negated. So vector 2D minus x minus y. Okay, that's it. Our vector now has maybe I can also write this here, operator overloading capability. Our vector now has perfect operator overloading capability, and in order to test it, let's create another class, test vector 2D. Okay, in this class I just create a main method, and let's define vector 2D v1 new vector 2D, let's say 0 and 1. Vector 2D v2 new vector 2D 1 and 2. All right, and let's also maybe override the toString method to be able to quickly. So from the object I'm going to, instead of first member, I'm going to it doesn't matter where to put it. Let's put it after the constructor. Okay, let's put it here, and then return let's just return brackets, or maybe just parentheses, plus x plus comma plus y plus close brackets. Okay, that's a very simple toString. All right, let's see, system.out.println v1. So far nothing out of usual for Java. We define an object through a constructor, everybody does that. We overrode the toString method, so this is basic Java, right? 0 1 1 2. But now in a typical object-oriented programming, if I want to have the vector 2D v3, which is v1 minus v2, I have to write something like this, minus v2, right? Use the method way of subtracting two objects. However, since I have already implemented the operator overloading for subtract, I can write this, and the compiler, notice the compiler does not complain because I already have installed the Scala plugin and the operator overloading extension for Eclipse. Okay, so the compiler doesn't complain anything, no error, and the beauty is here. So this is the beauty, this is the beauty. System.out.println v3. So what do we expect to get? V minus v2, so it's a direct subtraction, so it's v1 minus v2, minus 1 minus 1, let's see, minus 1 minus 1, and this minus now operates on two arbitrary object, vector 2D, and the way it do it, it uses these methods. First of all, these have to be public, just remember that. So the value of, if you implement value of, it has to be a static public, and this overloading method, they have to be public method as well. Okay, so right now I use subtraction, and basically what happens behind the scenes, that the compiler now knows how to interpret this code. So basically what compiler does, when it compiles and generates the bytecode, compiler generates the bytecode for this, right? This v1 So new vector 2D v1 dot or basically compiler generates the code for this v1 dot subtract vector 2D v2. Okay, I mean obviously I could just it complains because I have already declared another variable v3. So compiler basically replaces v1 minus v2 with this code and generates the bytecode. Okay, so behind the scenes this happens. By default the Java compiler doesn't know how to do it, only knows to do it for wrappers, double, int, float, that are built into the Java JDK. But now through this operator overloading extension, it understands how to do it for any type of object. Okay, now obviously instead of writing this, I could just simply call this method v1 dot subtract v2, and that's perfectly fine. Okay, but now there are other things that are very easier and more natural. For example, let's say I want to do v2 minus v1. So compiler calculates this and then calls the v2 minus v1, the result in an object is an object, and then compiler calls the toString method on the object, the result, the object result. So v2 minus v1 should be 1 1. Correct. Now if you remember, we also implemented the negate. So minus v1, compiler knows that it has to call the negate method. Okay, and what about plus plus? Now it doesn't understand, because I mean it doesn't make any sense to define a method for plus v1. Mathematically we just say v1, right? And because I don't have any overloading, any unary operation, so unary operation minus was defined, but not plus v, because it doesn't make sense to define something like this. We just simply say v. Okay, so that's why the compiler is complaining, because it says I don't know how to act on v1, which is a type, the type is vector 2D, and I don't know how to interpret plus v1. But for negative it doesn't complain, because behind the scene what it does, so what compiler does is system.out.println v1.negate. Okay, even the programmer, the user, can also do that. But we went through this implementation of writing all this tedious code and implementing the logic of operator overloading. So you implement it once and that keeps your code much cleaner. So it's much cleaner to say negative v1 instead of saying that v1.negate. But it's perfectly fine, and you can use it and do the usual operator overloading, do the usual object-oriented programming with this kind of method, the usage of method. Okay, now the cool thing here is that this could actually be the base, this kind of operator overloading when you're dealing with functions could be the basis of creating a symbolic math library in Java, and I'll talk about it in the next video. Alright, thank you very much. I hope you enjoyed this video. Please share and subscribe, and I'll see you next time.